This is going to be examples 3, part B and C from class, the parts that you were to do on your own, and here's just the solution. So we already have a demand curve in part A, and just as a reminder, it's important to look at what units we had in our demand curve. So let me just flip. Okay, so our demand curve that we already did in class, for example 3A, was this. And so the units are important. So P is going to be the price in dollars. And Q is going to be the number of phones demanded in thousands. Okay, so that's going to be important as we now try to come up with our supply curve. So let's go back now to B. So now suppliers are prepared to supply 2.1 million phones at $400 a phone, or 3.3 million at $600 a phone. So now we want a linear supply function for the phones. So again, we want to come up with a supply function where our independent variable is the price. We're going to use Q again to give the quantity supplied. P is going to be the price. And we want to use the same units that we've been using for demand. And we want to do that because we know in part C we're going to try to find the equilibrium. So we need the quantity demanded and quantity supplied to be in the same units. So we're going to get two ordered pairs here that we're going to use to find our linear function. So we're going to have price first. So we have $400 per phone. How much was supplied? 2.1 million, but we need to actually rewrite that in terms of thousands of phones. So that's going to be 2,100,000 phones. Okay, and same thing for the other order pair. We're going to get $600 per phone, and in that case we're going to sell 3.3 million or 3,300 phones. Excuse me, we're going to supply. This is not talking about the amount sold, it's the amount supplied. Alright, so here are our two ordered pairs, and now we just need to find the equation of the line that goes through the two. So we'll start out, here's our general form. So we want to find both M and B. So to find your slope, we're going to get, okay, and how can we interpret this? So first of all, it's good it's positive, because in general, the slope of our supply curve for most products is going to be positive. So this tells us that the number of iPhone suppliers are willing to supply are increasing 6,000 phones per $1 increase in the price of the phone. Okay, and it's a 6,000 because, again, the units of Q are in thousands. Now we want to solve for B. So we're going to you get to pick any of the 2 points. So I'll just pick the first one. So this is going to tell us that B is going to be negative 300. So we put that all together, and we get that our supply function is given by this. Okay, and you may be wondering, does it make sense to have a Q-intercept that's negative? So what does that tell us? That tells us that if the price of the phone is set to 0, suppliers are willing to supply a negative number of phones. Okay, there's no such thing as a negative number of phones. This is telling us that suppliers are definitely not going to supply you any phones if the price is 0, and in fact the price is going to have to be at least $50 in order for suppliers to want to supply more than 0 phones. Okay, and what I did there is I just said what is the price when Q is 0, and that would be 50. So that's fine. This is just a supply model, but it seems reasonable in our results. So now let's use both of our demand and supply curves to figure out the equilibrium. And it's helpful when we're picturing what the equilibrium means. It's helpful to actually graph our supply and our demand curves. So our demand has a Q-intercept of 2,700 and then has a negative slope. So it's doing something like this. And we can even find the P-intercept. If you let Q be 0 and you solve for P, we're going to see that P has to be $670. So that's what's right there. Oops, it's actually $675. Okay, so that's $675, and then let's plot the supply. So the point where they intersect is the equilibrium point. So, and why do we call it the equilibrium point? Let's look at what happens to the left. So over here, my demand is greater than my supply, so we have what we call a shortage. And over here, my supply is greater than my demand, so then we have a surplus, we have too much product. So we'd like to be right in this middle spot with the equilibrium point. So we'd like to figure out what is the price, what's our equilibrium price, and then what's the demand level that's at this equilibrium point. So to do that, we're just going to see where the two equations intersect. So we set these two lines equal to each other, and then we're just going to solve for P. So this tells us that the equilibrium price for the iPhone is going to be $300. And let's look at what the demand will be. What's the equilibrium demand? You can plug it back into either the demand or supply function. So I'm going to get -4 times 300 plus 2,700, which is going to give me 1,500, or 1.5 million phones. So the ideal price that we should set the phone at based on these demand and supply curves is going to be $300 per phone. And at that price, we will estimate that we're going to sell and supply 1.5 million phones.